Welcome to the Deep Dive, where we try to cut through the noise on some really big topics. And today, well, it's artificial intelligence. It's everywhere, right?
Absolutely everywhere.
And it's often painted in these really stark terms,
Hmm.
utopian dream or total dystopian nightmare.
Right, the extremes get all the attention.
Yeah. But what if the reality is, a lot more nuanced? And more importantly, what if we could actually design AI intentionally to help solve some of humanity's biggest, most urgent problems?
That's exactly where we're headed today. We're doing a deep dive into AI for social good, or AI for good, as it's often called.
AI for good.
Yeah, it's this whole movement about harnessing AI's power, which is immense, but not just for profit. It's about using it to speed up progress on these huge global challenges, things like climate change, disease, inequality, the big stuff.
So navigating that sounds pretty complex. Where are we drawing our insights from for this?
We're working from a really comprehensive report that digs into this dual nature of AI. It highlights the incredible positive potential, but it doesn't shy away from the challenges, the inherent risks either.
Yeah.
So our mission for you listening is to really unpack this intricate balance. We want to explore the promise of AI, but also, crucially, look at what the report calls the algorithmic shadow.
The algorithmic shadow. I like that framing.
Yeah, it captures that darker side. The goal here is to give you a shortcut, a way to understand what it really takes to build a future that's, well, just and sustainable with AI as part of the picture.
Right, because it seems like it will be part of the picture one way or another.
Exactly. So this idea, this AI for good imperative, it's not some fringe concept anymore. It's rapidly becoming institutionalized. It's a field really dedicated to applying AI technologies directly to social, environmental, economic challenges.
And with a deliberate focus, you're saying.
Yes, a deliberate focus on positive outcomes for, human well-being. It's about intentionally steering AI towards benefiting humanity.
And the timing for this feels, well, incredibly urgent. The backdrop is quite stark, isn't it?
It really is. You look at the UN's 2023 Sustainable Development Goals, report the SDGs. There's 17 big goals for 2030.
Yeah, everyone knows the grid of icons.
Right. Well, the report was pretty sobering. We're past the halfway point to 2030, and progress has stalled or even gone backwards on something like 80% of the specific targets.
80%? Wow.
Yeah, only about 15% are actually on track. That's a massive gap in implementation.
Yeah.
And it's made worse by, climate change, conflicts, the lingering effects of the pandemic.
So it creates this powerful narrative, this need for completely new solutions or at least new approaches.
Precisely. And in that context, AI isn't being pitched as some kind of magic wand, a panacea.
Okay, that's good.
But it is seen as a critical catalyst. What's really striking in the report is the finding that AI could potentially help enable progress on as many as 79% of the 169 specific SDG targets.
79%, that's huge.
It's a massive potential impact. It's seen as maybe breathing new life into this global agenda that's clearly struggling.
Okay, so if the potential is that big, how do we actually do it? How do we make AI work for good? The report must lay out some kind of framework.
It does. It highlights three foundational pillars that AI for good proponents consistently talk about. Those are inclusivity, sustainability, and ethical governance.
Okay, let's take those one by one. Inclusivity, how does AI help there? Isn't there a risk it just widens the gap?
That's the critical question, and inclusivity aims to tackle it head-on. The goal is to make sure AI's benefits are shared equitably, that it helps bridge the digital divide, not make it worse.
So practically, what does that look like?
It means things like democratizing access, better education, healthcare, economic opportunities for more people, and practically, designing AI tools that are accessible, usable by people with disabilities or with limited resources.
And adapting them, I guess.
Absolutely. Localizing them, making them relevant to specific cultural contexts, language contexts, and a huge piece is capacity building.
Meaning training people.
Yeah, equipping marginalized communities with the skills, the AI literacy, so they're not just passive recipients, but can actually participate, maybe even develop their own solutions, making sure they're not left behind in this transition.
Okay, inclusivity. The second pillar was sustainability. That seems like a more obvious fit, maybe?
It does feel like a natural alignment. This pillar is all about leveraging AI for global environmental efforts.
Give us some examples.
Well, environmental monitoring is a big one. Using AI to track things like air pollution, deforestation, biodiversity loss with much greater precision.
Okay.
Then there's smart agriculture. AI can help optimize farming, boost crop yields, while crucially minimizing the use of water, energy, fertilizers.
And disaster response.
Definitely. Disaster prediction. AI models can analyze huge amounts of data weather patterns, sensor data, historical trends to forecast things like floods or hurricanes much earlier and more accurately. That improves response times, saves lives.
Makes sense. Okay, the third pillar, ethical governance. Given AI's power, this feels like, well, the absolute bedrock.
It has to be. The report makes that clear. Recognizing the profound ethical questions AI faces, this pillar is all about prioritizing responsible and ethical deployment.
What are the core components of that?
The main goal is ensuring AI actually benefits society without making existing inequalities worse or creating entirely new risks. So, number one is mitigating bias, promoting fairness, making sure algorithms don't discriminate based on race, gender, socioeconomic status, you name it.
Which is a huge challenge in itself.
The massive challenge. Then there's transparency. We need to be able to understand at some level how these AI systems are making decisions, especially high-stakes ones. It can't just be a black box.
Right.
And finally, accountability, holding the developers, the deployers, the users of AI responsible for the societal impacts of their systems.
Okay, so inclusivity, sustainability, ethical governance, that's the what. But who is driving this? Who are the major players in this global AI for good ecosystem? It sounds like it must be a huge collaborative effort.
It really is. It's this powerful, interconnected global ecosystem. You've got international bodies like the United Nations providing the big picture, the ethical frameworks, the development goals like the SDGs.
Oh, look.
And specifically the ITU, that's the UN's Agency for Information and Communication Tech. They're a really central convener here. They organize the big annual AI for Good Global Summit in Geneva.
I've heard of that.
Yeah, it brings together like 40 plus UN agencies, governments from all over, the big tech leaders, civil society groups, all trying to advance AI applications and partnerships for good.
And the big tech companies themselves, obviously they're huge players. They have the tech, the resources.
Absolutely critical players. You see examples like Microsoft's AI for Good Lab. They set that up back in 2018. It focuses specifically on AI solutions for sustainability, humanitarian action, health, often explicitly linking projects to the SDGs.
Okay, and Google.
Google.org, their philanthropic arm, launched a big $25 million open call specifically for organizations using AI to tackle the global goals. And that builds on years of similar funding and support they've provided.
So the giants are involved?
Yeah.
Any others?
Yeah, beyond the huge corporations, you also have dedicated nonprofits popping up, like the AI for Good Foundation. They're actually deploying AI-driven solutions on the ground in areas like humanitarian aid coordination and refugee assistance.
The report suggests this isn't just straightforward philanthropy, right? It mentions a more complex dynamic, something about a geopolitical and corporate narrative being woven in. Can you unpack that a bit? That sounds important.
It's really fascinating and, yes, super important context. What the report highlights is that this convergence, international organizations providing the platforms and legitimacy, tech companies providing the solutions and resources, it goes beyond pure altruism.
How so?
Well, for international bodies like the ITU, hosting these summits and shaping discussions is a way to assert their relevance. It positions them as key players, guides in the governance of this incredibly disruptive technology.
Okay. Makes sense for them. What about the tech giants?
For the big tech companies, participating heavily in AI for good provides what the report calls a social license to operate.
A social license.
Yeah, it positions them as benevolent, indispensable partners in solving the world's problems. Think about the PR value. But more deeply, this framing helps shape the global conversation about AI governance in ways that often favor their interests.
How does it do that?
It tends to emphasize voluntary codes of conduct, multi-stakeholder initiatives, which sound good rather than potentially more restrictive, binding regulations. It keeps them at the table, often in the driving seat.
So if you connect the dots here, what's the bigger picture implication of this interplay?
It means that by consistently framing AI as the key solution, maybe even the only solution, to lagging progress on things like the SDGs, a sense of, well, technological inevitability is created.
Right. We need AI to fix this.
Exactly. And this fosters this symbiotic relationship. Tech companies gain legitimacy, influence over global policy agendas. International bodies reinforce their convening power and relevance. So the good in AI for good becomes this vehicle for soft power, for market positioning, and crucially for shaping the future rules of the game. It's a very sophisticated interplay.
Wow. Okay, that adds a really critical layer of understanding. So let's shift from the conceptual and the political dynamics to the concrete.
Yeah.
What are some actual real-world examples of AI being used effectively to solve some of these global problems?
Looking at the successful case studies, the report identifies a really consistent pattern. The most impactful AI for good applications aren't these, autonomous, all-knowing systems that just parachute in and fix everything.
Right, not the sci-fi version.
Not at all. Instead, they function more as what the report calls last-mile augmentation tools.
Last-mile augmentation, what does that mean?
It means their success comes from amplifying existing human expertise or overcoming very specific, well-defined bottlenecks in existing systems. They're not replacing humans. They're extending their reach or capability at a critical point.
Okay, that's a helpful concept.
Yeah.
Can you give us a strong example, maybe starting with climate and environment SDG 13?
Sure. Google's flood forecasting initiative is a really powerful case study here. They started piloting it in India back in 2018.
Okay.
Now it provides flood warnings in over 100 countries, covering something like 700 million people globally by 2024. The key thing is, many developing nations, which are often the most vulnerable to floods, lack the dense network of river gauges and hydrological data you find elsewhere.
Right, the basic infrastructure isn't there.
Exactly. So Google's approach uses machine learning, trained on available data and satellite imagery, to generate accurate predictions even in unmeasured locations. It fills that data gap.
And why is that so critical?
Well, the report notes that something like 90% of the 1.8 billion people globally who are at high risk from floods live in low and middle income countries. And studies show that early warnings, the kind this system provides, can reduce fatalities by as much as 43%. That's huge.
That is a massive impact.
Yeah.
Okay, what about health and well-being, SDG 3?
In global health, AI is really stepping in to augment healthcare capabilities, especially where resources are scarce. A great example is RADAID.
RADAID?
Yeah, it's an organization supported by a Google.org grant. They're using AI to tackle the critical shortage of radiologists in many low and middle income countries.
There just aren't enough specialists to read x-rays and scans.
Exactly. Millions lack access. So RADAID uses AI algorithms to help triage cases and provide preliminary interpretations of medical images, like x-rays. They're focusing on high-impact areas like detecting respiratory diseases or breast cancer earlier.
So it helps prioritize.
It helps prioritize, and it provides a first read. The aim is to improve diagnostic access for over 30 million people across 20 countries. Again, it's not replacing doctors. It's giving the existing healthcare system a powerful tool to extend its reach.
Right, amplifying the experts they do have. Okay, let's move to agriculture and food security, SDG 2. How's AI helping farmers, especially maybe smallholders or those in remote areas?
The Ulangizi chatbot in Malawi is a really compelling example here. It was developed by Opportunity International.
Ulangizi, what does that mean?
It means advice in Chichewa, the local language.
Yeah.
And that's what it does. It's a generative AI tool like a chatbot.
Okay.
But crucially, it communicates in Chichewa. It gives farmers tailored guidance on things like managing their crops, optimizing irrigation, adapting to changing climate patterns.
In their own language, directly on their phone, maybe?
Exactly. It makes expert agricultural knowledge accessible through a simple, language-appropriate interface. This empowers farmers to make better decisions, hopefully leading to better yields and more food security. And think about the scalability and cost-effectiveness compared to traditional methods, like sending extension workers out to every village.
Yeah, you can reach so many more people. That's a brilliant example of meeting people where they are. Okay, finally, humanitarian aid and justice, SDG 16.
Here, you see AI being used to streamline aid and provide crucial information. LifeForce Ukraine, developed by the AI for Good Foundation, is described as Ukraine's largest humanitarian aid matching system.
Wow. How does that work?
It essentially gives civilians real-time access to information about where they can find food, shelter, medicine, other services across something like 37,000 different service locations. It's about connecting need with supply efficiently in a crisis.
That's vital. Any other examples in this area?
Another really interesting one is the International Rescue Committee's Signpost project. They use AI-powered chatbots to help displaced populations, refugees, internally displaced people.
What kind of help?
The chatbots provide reliable 247 answers to common questions about available services, legal rights, safety information, things people desperately need to know in confusing and dangerous situations.
But how do they ensure the information is accurate and appropriate? That seems critical.
Absolutely. And the crucial element here is what they call a human-in-the-loop design.
Human in the loop.
Yeah. It means that local human moderators review the AI's responses before they go out, or review patterns of responses. They ensure the information is not just accurate, but also culturally sensitive and contextually appropriate for that specific community. It's this hybrid model combining the scalability of AI with the nuance, the trust, and the local knowledge of human oversight.
That really brings us full circle back to that last mile augmentation theme you mentioned earlier. It seems like in all these successful cases, AI isn't the hero on its own.
Exactly. It's not about AI replacing humans, but enabling them, augmenting them. Ulonjizi solves a communication and accessibility bottleneck.
Right.
Google's flood model addresses a critical data bottleneck.
Okay.
RAD-Aid and the AI-assisted diagnostics tackle a human resource bottleneck, and Signpost addresses both information access and trust bottlenecks through that hybrid approach.
So the pattern really challenges that simplistic idea of techno-solutionism, that tech alone will save us.
It absolutely does. The report argues that AI's true value, at least in this social good context, lies in its deep integration into existing human systems, social infrastructures. It acts as a connector, maybe a translator, a data interpolator, but always within a collaborative, human-centric system.
Okay, so that's the promise. The potential is clearly immense, transformative even, when applied thoughtfully.
Yeah.
But now we have to turn to the other side of the coin.
The shadow.
The report is very clear. Focusing only on that optimistic narrative would be, frankly, dangerously naive. There's this significant algorithmic shadow, these systemic costs, these harms that are deeply embedded in how AI is currently built and deployed. We have to confront this directly.
We really do. It's not just about unintended consequences. It's often about predictable structural issues.
So let's start with what the report calls the material shadow. This is about the physical reality behind the algorithms, the energy, the e-waste, the whole supply chain.
Yeah, it's easy to think of AI in the cloud as being, ethereal, immaterial, just code floating somewhere.
Weightless.
But that masks this profoundly physical reality. The AI revolution is built on massive physical infrastructure, huge data centers, complex supply chains for chips, undersea cables, and this infrastructure has a voracious appetite for energy and creates a rapid cycle of hardware becoming obsolete. This casts a really long environmental shadow.
And the energy demands. The numbers I've seen are just staggering.
They are immense, and they're growing exponentially. The report projects that data centers, which are the physical hubs powering AI, could more than double their global electricity demand by 2030.
Double. From where?
Reaching an estimated 945 terawatt hours annually. To put that in perspective, that's slightly more than the entire current electricity consumption of Japan.
Wow.
And look at training a single large language model. Something like GPT-3, its training consumed an estimated 1,287 megawatt hours of electricity. That's enough to power an average U.S. household for about 120 years.
Just for training one model.
Just training it once. And another model, Bloom, its training was estimated to emit 25 times more carbon than flying one way from New York to San Francisco. This massive energy use directly contributes to greenhouse gas emissions, especially since so many data centers still rely heavily on fossil fuel-powered energy grids.
Okay, so the energy footprint is enormous. And beyond that, there's the problem of e-waste.
Yes. The sheer pace of innovation in AI hardware, especially those specialized chips like GPUs needed for training and running complex models, it creates this accelerated obsolescence.
Meaning older stuff gets useless really fast.
Pretty much. As newer, more powerful chips come out, the hardware required to stay competitive changes rapidly. Older generations become less viable, less efficient. This rapid turnover is a huge contributor to the global electronic waste crisis,
Which is already a massive problem.
one of the fastest growing waste streams worldwide. And e-waste is nasty stuff. It contains valuable metals, sure, but also toxic substances like lead, mercury, cadmium. If it's not managed properly, it poses severe risks to the environment and public health, especially in the places where a lot of this waste ends up being processed, often informally.
Okay, this is grim. So what are the potential solutions? How do we architecturally address this material shadow? It sounds like we need action on multiple fronts.
Absolutely. It requires rethinking AI systems from like the fundamental physics all the way up to economic policy. On the hardware front, there are really interesting innovations. The report mentions research at Clemson University on a new polymer material
Okay.
that can be used to build something called a memristor. Think of it like a component that can both store information and process it in the same physical location.
Instead of constantly moving data back and forth between memory and processor.
Exactly. That data shuffling consumes a huge amount of energy in current chips. Memristors could potentially dramatically reduce AI's energy consumption at the most fundamental hardware level.
That sounds promising, but probably long term. What about software? Can we optimize the code?
Yes, software optimization can make a big difference much faster. Researchers at the University of Michigan developed an open source framework called Zeus.
Lose.
Yeah. Apparently, it can cut the energy used for training AI models by up to 75% with only minor impacts on how long the training takes.
How does it do that?
Essentially, it monitors the training process in real time and dynamically adjusts things like the GPU's power limit and the batch size, how much data it processes at once to find the sweet spot that minimizes energy use for a given speed target.
Clever.
And they developed another piece of software called Chase, which adds another layer. It's carbon-aware computing.
Carbon aware.
It means Chase makes decisions based on the real-time carbon intensity of the electricity grid. So if the grid is running on lots of solar or wind power right now, it might prioritize speed. But if the grid is relying heavily on coal or gas, maybe during peak demand, it will prioritize energy efficiency, even if it slows things down a bit.
So it tries to use the greenest energy available.
Exactly. It links computational decisions directly to their environmental impact in real time.
Okay, hardware innovation, software optimization. What about the devices themselves? The life cycle. You mentioned e-waste.
Right. The third piece is shifting towards a circular economy for AI hardware. This starts with sustainable design principles. Maximizing energy efficiency from the start, using materials that are easier to recycle or have lower environmental impact, designing for modularity so components can be upgraded or repaired easily, extending the device's useful lifespan.
Are companies doing this?
Some are starting. The report mentions Dell having closed-loop recycling programs where they collect old products, refurbish them for resale, or recycle the materials into new products. HP has explored hardware as a service models.
Where you lease the device instead of owning it.
Yeah. And the incentive for the manufacturer is then to make devices that last longer and are easier to refurbish and reuse when they're returned at the end of the lease.
And AI itself could help with the recycling process. That sounds a bit ironic.
It is, but yeah. AI-driven computer vision systems can actually automate the sorting of complex e-waste streams. It's hard for humans to quickly identify all the different materials and components, but AI can be trained to do it, improving the efficiency and purity of material recovery.
Okay, so technical solutions, new business models. But the report also argues these might not be enough on their own. It pushes for a more systemic intervention, specifically mentioning a carbon tax for computation. How would that work?
The argument is that while these voluntary tech fixes and circular models are good, AI's exponential growth in energy demand might just outpace them. A carbon tax for computation aims to internalize the environmental costs that are currently, externalized.
Make the polluter pay.
Exactly. A price would be set for each ton of greenhouse gas emissions produced by the energy used for computation. This tax could be levied upstream, maybe on the data centers themselves, or the utilities supplying their power.
And the idea is to create an economic incentive.
Precisely. The tax rate could be linked to the scientifically estimated social cost of carbon, and maybe it escalates over time. This sends a clear market signal. Investing in energy-efficient hardware, using optimization software like Zeus and Chase, sourcing renewable energy. These become economically rational decisions, not just nice-to-haves.
What would happen to the revenue from such a tax?
That's a key policy design question. It could be reinvested into research and development for green AI technologies, or used to fund the transition to renewable energy infrastructure specifically for data centers. Or some proposals suggest returning the revenue directly to the public as a carbon dividend to offset any potential regressive impacts.
This whole discussion about energy and materials brings us to a really interesting point. The report calls the sustainability paradox. Can you explain that?
Yeah, it's a crucial tension. The paradox is that many of the AI applications being developed for sustainability, things like complex climate models, systems for monitoring deforestation, platforms for validating carbon credits, are themselves incredibly computationally intensive.
So the solutions consume a lot of the resource they're trying to manage.
In a way, yes. Their operation contributes, sometimes significantly, to the very environmental problems like energy consumption and emissions they aim to solve. This creates a real dilemma.
And the risk.
The risk is that without mandatory frameworks, like a carbon tax or strict efficiency standards, the voluntary adoption of sustainable AI practices might simply be insufficient to offset AI's explosive overall energy and material footprint. You could end up in a situation of greenwashing, where these beneficial environmental applications are highlighted, while masking a much larger growing environmental debt from the underlying infrastructure.
So we need a full picture.
We need comprehensive, life cycle-based accounting of AI's environmental impact, enforced by robust policy. Otherwise, the promise of AI for environmental good could end up being, well, a mirage, built on unsustainable foundations.
That's a really sobering point.
Oh.
Okay, let's shift gears now from the material shadow to the socio-ethical shadow. The report argues this goes beyond just bias that needs patching. It talks about systemic harms, historical patterns of power being replicated. Can you explain the concept of digital colonialism?
Yeah, this is a really critical framework in the report. Digital colonialism describes how a relatively small number of powerful tech corporations, predominantly based in the global north, design and deploy digital infrastructures, hardware, software, platforms, standards in ways that primarily serve their own economic interests.
Okay.
But in doing so, they establish a kind of global dominance, creating deep societal dependencies around the world on their technologies and their ways of organizing information. It's not just about market share, it's about shaping the very fabric of the global digital landscape.
And the report links this to linguistic and cultural imperialism. That sounds strong.
It's a stark point, backed up by examples. The report highlights, for instance, that as of May 2024, the leading AI voice assistants, Siri, Google Assistant, Alexa, collectively supported 0 of the approximately 2,000 distinct languages spoken across the African continent.
0 out of 2,000.
0. And Africa is home to roughly a third of the world's linguistic diversity. This isn't just some neutral oversight or technical limitation that will eventually be fixed. The report argues it's a profound form of cultural erasure.
How so?
It reflects the inherent biases of the small, relatively homogeneous group of engineers, predominantly white, male, American, who design these core systems. It reinforces the global dominance of English and a few other major languages, effectively marginalizing countless other ways of speaking, thinking, and being. It makes the digital world feel alienating, unusable for vast numbers of people.
Wow. And it goes beyond language, doesn't it?
Mm-hmm.
The report mentions surveillance and even extractive benevolence.
Yes, AI-powered surveillance technologies are being deployed globally, often in ways that replicate and even amplify historical patterns of injustice and racialized control. The report gives the example of Vumacam in Johannesburg, South Africa.
What's that?
It's a private company operating a network of over 5,000 CCTV cameras across the city, using AI analytics, including facial recognition technology, which is known to have significant racial biases, performing less accurately on darker skin tones.
And the concern.
Local activists argue this system essentially reinforces the spatial and racial inequalities inherited from the apartheid era, creating zones of intense surveillance predominantly in wealthier, historically white areas, while potentially misidentifying people in other areas. It's using new tech to entrench old divisions.
And extractive benevolence. That sounds like a contradiction.
It is. It refers to a key tactic of digital colonialism, masking fundamentally extractive economic practices behind a veneer of philanthropy or doing good. The classic example given is Facebook's Internet.org initiative, later rebranded as Free Basics.
I remember that. It was pitched as connecting the unconnected, giving free internet access.
Exactly. Connecting the world was the slogan. It was heavily promoted, especially across Africa, Asia, and Latin America, as a way to bridge the digital divide. But leaked internal documents, cited in the report, revealed a different story.
What do they show?
They showed that users in developing countries accessing these supposedly free services were often secretly being charged by their mobile carriers who had deals with Facebook. These charges amounted to nearly $100 million in just 2021. So, while promoting connection, the platform was also facilitating significant wealth and data extraction from some of the world's most vulnerable populations.
That is truly eye-opening. Wow. Okay, alongside digital colonialism, the report introduces another concept, Aesthetic injustice. What does that mean?
Aesthetic injustice focuses on how AI systems learn, perpetuate, and even globally standardize very narrow, often biased ideals of beauty.
How did that happen?
Well, think about where AI models learn from. They're often trained on massive data sets scraped from the internet, images, text, and that data is saturated with existing societal biases about beauty.
So they learn our biases.
They learn and amplify them. This often means reinforcing dominant, often Eurocentric, ideals of beauty. Certain skin tones, facial features, body types are implicitly coded as more desirable or normal than others.
And where does this show up?
It shows up in AI applications used for things like facial analysis, photo filtering, even recruitment tools that assess candidate videos. These systems can end up evaluating people based on these biased, learned standards. It marginalizes and devalues diverse forms of beauty that don't conform to the dominant norm.
So it's not just reflecting bias, it's actively promoting a single standard.
Yes, it risks actively promoting a single hegemonic standard globally. This can contribute to what psychologists call appearance-based stress and anxiety. And fundamentally, it replaces nuanced, subjective human understandings of beauty and appearance with rigid, often unfair, algorithmic judgments.
These are deep structural problems. Digital colonialism, aesthetic injustice. How does the report suggest we even begin to address harms this profound? It introduces the idea of epistemic reparations. What is that?
The core argument is that the harms we've just discussed, the silencing of languages, the erasure of cultures, the imposition of standards, are fundamentally epistemic harms. They are harms related to knowledge, recognition, and the very right to define one's own reality.
Epistemic meaning related to knowledge.
Exactly. So, epistemic reparations moves beyond the traditional idea of reparations as just, say, monetary compensation for past wrongs. It focuses instead on repairing the harm done to a people's ability to be known, to have their knowledge validated, and to tell their own stories.
Where does this concept come from?
It has roots in work with survivors of profound injustices, like state violence, incarceration, sexual violence, recognizing that a crucial part of justice and healing involves creating the space and resources for victims to counter the dehumanizing narratives imposed on them, to assert their own experiences and have them heard and acknowledged.
And how does this connect directly to AI?
The connection is this. When an AI system fails to recognize your language, implicitly devalues your cultural expression of beauty, ignores your history, or perpetuates harmful stereotypes about your community, it's committing an epistemic wrong. It's implicitly declaring that your knowledge, your culture, your way of being, your very experience of the world is somehow less valid, not worthy of being represented in this new digital reality.
So if we really take that seriously, the implication is huge.
Yeah.
The deeper harm here isn't just, say, getting an unfair loan denial because of biased data.
Exactly. That's a biased output, and it's bad.
Yeah.
But the report argues the deeper, more insidious harm of digital colonialism and aesthetic injustice is that implicit message. Your language isn't valid, your culture isn't sophisticated enough, your appearance isn't right, your history doesn't matter, your whole way of life isn't worth including in the digital future we're building.
That's an assault on someone's reality, their ontology, as the report puts it, their very way of being in the world.
Precisely. It's an assault on their ontology. And reframing the problem this way shows why simply fixing the bias within the existing AI architectures might be necessary, but it's profoundly insufficient because the architecture itself, built on this flawed, universalist, often colonial foundation, is the problem.
So what's required then?
What's required, the report argues, is a fundamental architectural shift. We need to move beyond just corrective measures and demand solutions that actively resist this erasure. Solutions that are not just less biased, but are designed from the ground up to be structurally, foundationally pluralistic.
Okay, this critique is deep and powerful. It logically leads us to the next major part of our discussion: architecting a new foundation for AI. If the current foundations are flawed, how do we build better ones? We can't just patch. We need to proactively embed things like accountability, relationality, human centricity right into the design.
Exactly. It's about building differently from the start.
So, let's begin with the technical architectures needed for trust and accountability. How do we get beyond these opaque black box models where we don't know why the AI did what it did?
Yeah, building trust, especially when AI is used in high-stakes areas like healthcare or finance or justice, is paramount. We absolutely have to move beyond opaque systems. A key step highlighted in the report is the development and adoption of what's called verifiable AI.
Verifiable AI. What distinguishes that from, say, explainable AI, XAI, which people might have heard of?
Explainable AI is mostly about trying to understand how a model reached a decision after the fact. Verifiable AI is broader and, in a sense, stronger. It refers to designing AI systems from the outset with transparency, auditability, and accountability baked in. The goal is to allow users, regulators, auditors to reliably trace, understand, and validate the system's decisions and behavior. It aims for a more robust guarantee of reliability and compliance.
Okay, and the report gets quite specific here, mentioning attestable audits in trusted execution environments, or TEs. That sounds very technical. Can you break that down for us?
It is technical, but the concept is powerful. Think of a T, a trusted execution environment, as like a secure, isolated vault built right into the computer's processor chip. It protects any code and data running inside it from tampering, even from the owner of the machine or the cloud provider.
Like a digital black box, but one you can trust.
Sort of, but one designed for verification. The attestable audit protocol uses this T. Here's how it could work. An AI model provider and an independent auditor both send their encrypted data, the model, the test data, the audit criteria into this secure TE.
Okay, so it's protected inside.
Right. Inside the TE, the audit process runs automatically. Crucially, the T can then produce a cryptographically signed attestation. This is like a digital, unforgeable certificate.
What does it certify?
It provides verifiable proof that this specific model was tested against this specific data using this specific audit procedure, and it achieved this specific result, like a certain fairness score or accuracy level. And it does this without revealing the provider's secret model internals, their IP, or the auditor's potentially sensitive test data to the outside world.
So you get proof without exposing secrets.
Exactly. It's like getting a notarized, unhackable receipt for an AI's performance check. This could transform compliance. Instead of companies just declaring they meet standards, they could provide verifiable proof. It shifts from self-attestation to objective, attestable fact.
That's a really powerful technical mechanism. But it raises the next question. Who decides what gets audited? Who sets the rules and standards that these verifiable systems need to meet? That's where the report brings in decentralized autonomous organizations, or DAOs.
Precisely. Verifiable AI and Ts address the how of technical accountability, but DAOs offer a potential answer to the who holds the power, who sets the rules. This is crucial for tackling that power concentration and digital colonialism we talked about.
So how do DAOs work in this context?
Well, DAOs typically operate on blockchain technology. Their rules are encoded in smart contracts, and decisions are made through transparent voting processes by their members. They offer a fundamentally different governance model than the top-down corporate structures we usually see.
And how could that apply to AI governance?
You could imagine a DAO being formed by the actual stakeholders of a particular AI system. Maybe it's the farmers using specific agricultural AI platform in a region, or the citizens subject to an AI system used by their local government for resource allocation.
So the users or those affected become the governors.
In essence, yes. The DAO members could collectively vote on the ethical principles the AI should adhere to, the specific fairness metrics it must meet, the risk thresholds it shouldn't cross. The AI system itself might provide data and analysis to inform these decisions, but the ultimate authority, the decision-making power, rests with the human members, ensuring the AI remains aligned with the community's values and needs. It's a direct challenge to that top-down governance by distant tech giants.
Okay, so we have verifiable tech and potentially decentralized governance. But shouldn't we be thinking about the impacts before we even build and deploy these things? The report mentions multimodal impact assessment.
Absolutely critical. Proactive anticipation, not just reactive fixes. The report emphasizes that these impact assessments shouldn't be just a one-time checkbox exercise before launch. They need to be iterative processes happening throughout the AI lifecycle.
Are there good models for this?
Yes, UNESCO has developed a comprehensive ethical impact assessment, EIA methodology, specifically for AI. It's quite robust.
What does it involve?
It starts with really fundamental scoping questions. Is AI actually justified for this problem? Have non-algorithmic alternatives been seriously considered? Is the proposed AI solution proportionate to the issue? Then it requires detailed stakeholder engagement, actually talking to the people who will be affected. It also includes assessing the diversity of the development team itself, recognizing that homogeneous teams often embed biases.
And the core evaluation.
The core is evaluating the proposed system against key ethical principles. safety, security, fairness, non-discrimination, sustainability, privacy, human oversight, transparency, accountability. It forces a systematic consideration of potential harms up front.
And in high-stakes areas like healthcare.
The World Health Organization, WHO, has issued guidance specifically for large multimodal models, LMMs, used in health. They call for not just pre-deployment assessment, but also mandatory, independent, third-party auditing after release. And crucially, they stress that the results of these audits and impact assessments must be disaggregated by demographics, age, race, gender, location, to actively detect and address any biases or disparities in how the AI performs for different groups.
So the burden shifts.
The burden shifts fundamentally. It moves from just reacting to harms after they occur to proactively designing ethical, safe, beneficial, and equitable systems right from the very beginning.
Now, if we try to connect these pieces, verifiable AI, DAOs, ethical impact assessments, it sounds like they're not mutually exclusive. The report suggests they could actually integrate into a really powerful layered framework.
That's the really exciting potential here, their synthesis. Imagine this. A community forms a DAO to oversee an AI system being deployed locally, maybe for managing public resources. This DAO formally adopts the UNESCO Ethical Impact Assessment methodology as its guiding framework.
Okay.
The specific ethical parameters, fairness metrics, and audit questions defined through that democratic EIA process are then encoded into the DAO's governing smart contract on the blockchain. This smart contract then automatically triggers periodic, attestable audits of the AI system. These audits are executed using that verifiable AI framework running inside a secure TE.
And the result?
The T produces that unforgeable cryptographic proof, the attestation, confirming whether the AI met the DAO's specified criteria during that audit period. This proof is then automatically published back to the DAO's blockchain, making it transparently available to all members.
Wow. So you're combining
the democratic legitimacy of the DAO, the procedural rigor of the EIA, and the technical verifiability of the T and attestable audits. It integrates community control, ethical foresight, and technical assurance into a single, much more robust foundation for trust and accountability than any one piece could provide alone.
That's a truly holistic vision for technical and governance architecture. But you also flagged earlier that technical fixes aren't enough if the underlying way the AI thinks its cognitive architecture is flawed. The report talks about needing cognitive architectures for relational intelligence. What does that mean, especially this philosophy of pluriversal AI?
Right. This digs deeper into the assumptions embedded in AI. The dominant view of intelligence in the West, often summarized by the acronym WEIRD, for Western, educated, industrialized, rich, and democratic, tends to see intelligence as something abstract, logical, quantifiable, disembodied, something that can be measured by IQ tests or computational benchmarks. And this view is deeply baked into how we currently design and evaluate AI systems.
But that's just one view of intelligence.
Exactly. It's a culturally specific understanding. Pluriversalism, which draws heavily on indigenous and other non-Western philosophies and cosmologies, offers a radical alternative. It challenges the very idea of a single, universal, objective reality or universe. Instead, it posits a pluriverse, a world composed of many interconnected but distinct worlds, or many different natures, many valid ontologies.
So multiple realities coexisting.
In a sense, and from this perspective, intelligence isn't some abstract processing power. It's fundamentally relational, it's embodied, it's deeply grounded in specific cultural contexts and practices. It's about becoming with others, with the environment, within a specific web of relations. Language isn't just a tool for describing a single reality. Language actively makes worlds. Each language, in a way, constitutes a different ontology.
So how does this critique the current AI alignment project? The goal of making AI safe by aligning it with human values.
From a pluriversal perspective, the Standard AI Alignment Project, which often involves trying to distill some universal set of human values, usually defined by a small group in the West, and then programming that into a single powerful AI, looks like a form of cognitive imperialism.
Cognitive imperialism.
Yeah. It's seen as an attempt to reduce the rich diversity of the pluriverse, all these different ways of knowing and being, into a single dominant monologue dictated by one specific culturally bound notion of reason and value. It risks erasing other worlds in the name of creating one supposedly aligned AI.
Okay, that's a profound philosophical critique.
Right.
How do you translate that into practice? How do you actually build or interact with AI differently based on this? The report mentions decolonial prompt scaffolding and context engineering 2.0.
Right, moving from theory to practice requires new methods. Decolonial prompt scaffolding adapts ideas from education, providing supportive structures to help learners navigate complex territory. But here, it's applied to interacting with AI. It means designing prompts very carefully, not just to get a better factual answer, but specifically to guide the AI away from its default, often biased or colonial thought patterns. It involves prompting the AI to reflect on its own potential biases, to consider alternative cultural perspectives, maybe even to engage with ambiguity or unsettling feelings rather than just giving a confident, simplistic answer. It's about using the prompt to encourage more nuanced, self-aware reasoning.
And context engineering 2.0.
This builds on that. Context engineering generally is about carefully managing the entire context window you provide to an AI model when you interact with it. This includes not just your direct question, the user query, but also the underlying system prompt that sets the AI's persona and rules, maybe some examples of good answers, few shot examples, and any external knowledge retrieved to help answer the query.
So controlling the input very precisely.
Yeah, exactly. Context engineering 2.0 takes this further, seeing it as a way to architect the AI's immediate cognitive environment. By meticulously crafting all elements of this context, developers can more effectively steer the AI towards responses that are not only accurate, but also culturally aware, ethically sensitive, and self-reflective, aligning more with pluriversal principles than default outputs might.
This sounds like it requires a different way of storing and organizing knowledge for the AI too, which leads to what the report calls the Pluriversal Knowledge Graph, or PKG. How is this different from the knowledge graphs companies like Google use now?
Standard knowledge graphs, like Google's, aim to represent facts about the world in a structured way, but they typically assume there's one single correct, objective way to structure that knowledge based on a single, usually Western scientific ontology. A pluriversal knowledge graph is designed fundamentally differently. Its core principle is to hold multiple, distinct, sometimes even contradictory ontologies and worldviews within the same structure, but without collapsing them into one. It preserves their integrity as separate, valid ways of organizing knowledge, perhaps as distinct subgraphs within the larger structure.
So it acknowledges different realities side by side.
Exactly. And this changes how an AI using it would operate. The AI's first step, guided by that sophisticated context engineering we just discussed, wouldn't be to just find the answer. It would be to identify the relevant cultural or ontological context for the interaction.
Like, is this user thinking in a scientific frame, or an indigenous frame, or a legal frame?
Precisely. Once it identifies the relevant context, say, indigenous Amazonian cosmology, it would then activate the corresponding subgraph within the PKG. All subsequent reasoning, information retrieval, and response generation would happen within the rules and relations defined by that specific ontological framework.
Wow, that's a huge shift.
It's a paradigm shift. It transforms the AI from aiming to be a universal translator, which inevitably distorts and erases nuances when forcing one framework onto another into something more like an ontologically fluent navigator. An AI capable of respectfully operating within different conceptual worlds on their own terms. This shifts the ultimate goal from achieving some kind of elusive, universal value alignment to cultivating ontological fluency, which is arguably much more aligned with truly serving the diversity of all humanity.
Ontological fluency, that's a powerful concept.
Yeah.
Okay, this connects to the third layer of re-architecting. Human-centric architectures for synergistic collaboration. The ideal vision here sounds appealing. AI does the grunt work, humans do the uniquely human stuff.
Yeah, that's the idealized model you often hear about, a clear, complementary division of labor. AI handles the repetitive, data-heavy, computationally intensive tasks, processing vast data sets, identifying complex patterns. Humans then focus on what are often called the uniquely human skills. Deep contextual understanding, ethical judgment, creativity, critical thinking, empathy, complex communication.
Can you give an example?
Sure. In customer service, maybe an AI analyzes call transcripts to detect patterns of dissatisfaction or predicts customer churn. But then a human agent uses empathy and nuanced communication skills to actually resolve the complex issue with the unhappy customer. Or an AI analyzes market data to spot statistical trends, but human strategists interpret those trends within the broader competitive landscape, craft compelling narratives, and make the final strategic decisions. This partnership is often termed collaborative intelligence, and the promise is enhanced productivity and innovation.
It sounds good in theory, but the report raises a serious question about whether this neat division is actually sustainable. It introduces the idea of a recursive replacement loop. That sounds less optimistic.
It is significantly less optimistic, and it's based on recent developments in AI itself. The potential disruptor here is what's known as recursive AI.
Recursive AI.
It refers to AI systems that are designed to learn and improve iteratively by analyzing, critiquing, and then modifying their own outputs or even their own internal processes in a continuous feedback loop. Think about it. This isn't just automating a specific task, it's automating the process of improvement itself.
Can you give an example of how that works?
The report mentions a method called reflection, which was used with GPT-4. Essentially, after the AI generated some code to solve a problem, it was prompted to act as its own critic. It would test the code, identify any errors or inefficiencies, verbally articulate what it did wrong, my mistake was not handling this edge case, and then use that self-critique to generate a new, corrected version of the code.
And did it work?
Remarkably well. This process significantly improved the AI's success rate on coding tasks, in one case from about 80% to 91%. What's key here is that the AI is learning to perform tasks previously thought to require human oversight: debugging, reflecting on mistakes, refining solutions. These are metacognitive skills.
Okay, I see where this is going. If AI can automate the improvement process.
Then it creates the risk of this recursive replacement loop. As AI models get better not just at doing tasks, but at the meta-tasks of self-correction, optimization, and learning new skills from feedback, the supposed synergistic zone, where humans uniquely contribute, starts to shrink.
The things only humans could do become the next things AI learns to do.
That's the fear. The tasks currently left for humans, maybe complex analysis, strategic refinement, even creative iteration, become the next targets for automation by these recursively improving systems.
Is this just theoretical, or is there evidence it's happening?
The report argues it's already starting to happen, pointing to economic realities. It cites Microsoft, a leader in deploying AI internally and externally. In 2024, they reported saving over $500 million in their customer service operations, largely through AI automation, while also announcing significant job cuts, over 15,000 positions.
Wow.
And perhaps even more tellingly, Microsoft's CEO noted around the same time that AI tools like GitHub Copilot were already writing something like 20–30% of the new code within their software repositories. That's AI directly encroaching on the core tasks of highly skilled software engineers.
So the conclusion is?
The conclusion drawn is that trying to define unique human value based on a specific set of functional skills that AI supposedly can't do. While that's likely a losing game in the long run, the goalposts keep moving.
So if functional skills aren't the answer, what is? How do we redefine human skill and value in the age of recursive AI? The report proposes this new paradigm, interestingly reappropriating the machine learning term EPOCH to create an acronym. EPOCH skills. What are these?
Right. The recursive replacement loop forces a fundamental rethink. The report argues that the only stable, defensible ground for long-term human value isn't functional, it's normative. It's our ability to ask why a task should be performed in the first place, to define its ethical boundaries, to provide the deep, pluriversal context that gives it meaning and purpose. The essential human role shifts from execution, or even just collaboration, towards normative direction and ethical governance of AI systems.
So EPOCH skills are about guiding AI, not competing with it.
Exactly. The EPOCH acronym cleverly uses epoch, which in machine learning means one complete pass of the training data through the algorithm to represent a set of uniquely human competencies needed to navigate this new era. These are the core capabilities required to guide and govern AI responsibly.
Okay, let's break down the acronym. What does the E stand for?
E is for ethical scrutiny. This is the capacity for critical analysis of AI systems and their impacts. It's about establishing and enforcing ethical guardrails, engaging in deep philosophical inquiry about values, anticipating unintended consequences, and facilitating democratic deliberation about which values AI should embody. Think about actively participating in a rigorous UNESCO ethical impact assessment, or contributing to the ethical rule setting within an AI governance DAO.
Okay.
P stands for purpose-driven direction. In a world where AI can optimize for almost any goal we give it, the crucial human task is defining the right goals. This is about setting the ultimate purpose for AI systems. It requires strategic foresight, a deep understanding of human needs, societal aspirations, and the wisdom to direct AI's immense power towards genuinely beneficial ends, like achieving the Sustainable Development Goals in an equitable way.
O must be ontological awareness, which we discussed with pluriversal AI.
Precisely. O is ontological awareness. This is the crucial skill of recognizing, respecting, and navigating the pluriverse, understanding that different cultures, communities, and knowledge systems have different valid ways of knowing and being. It's about ensuring these diverse ontologies are not inadvertently erased by universalizing technologies. Practically, it's the human insight needed to help build and curate a pluriversal knowledge graph, or to perform that careful decolonial context engineering when interacting with AI.
C is for contextual intelligence.
C stands for contextual intelligence. This refers to the deep, often tacit, embodied understanding of specific social, cultural, historical, and situational contexts that current AI systems, trained primarily on vast but decontextualized data, inherently lack. It's that last mile human wisdom.
Like the examples you gave earlier.
Exactly. It's the wisdom of the Signpost Project's local moderator who understands the specific rumors and fears circulating in their community. It's the expertise of the agricultural specialist who can take the Ulanjiti chatbot's generic advice and tailor it based on the specific soil conditions in this field and the weather forecast for next week. It's the crucial human ability to ground abstract information in concrete reality.
And finally, H.
H is for human-centric judgment. This represents the irreducible human capacity for empathy, compassion, nuanced ethical deliberation, and making holistic judgments in complex situations that simply cannot be reduced to an algorithm or a set of predefined rules.
Examples.
It's the legal professional's ability to consider the spirit of the law, not just the letter, in a unique case. It's the doctor's ability to weigh complex medical data against a specific patient's life circumstances, values, and preferences. It's the social worker's skill in building trust and understanding the unspoken needs of a vulnerable individual. These are judgments deeply rooted in human experience and values.
So this EPOCH paradigm, it's really suggesting a radical shift in education and workforce development, isn't it?
It really is. It implies that our focus should shift away from training people for specific, potentially automatable tasks and towards cultivating these higher-order, normative, relational, and contextual competencies. It argues that true, lasting human value in the age of AI lies not in doing things faster or more efficiently than machines, but in guiding them with wisdom, purpose, ethics, and a deep understanding of the human condition in all its diversity.
Mastering the art and science of guiding AI, as you said earlier. Okay. This brings us to our final major section, from architecture to action. We've talked about diagnosing the problems and architecting new foundations. Now, how do we translate this into concrete action? The report introduces the concept of generative justice. How does this go beyond just preventing harm?
Generative justice is about moving beyond a purely defensive posture, just mitigating risks, avoiding bias, preventing harm. It's about proactively harnessing AI's capabilities to actively create positive outcomes, particularly for marginalized communities, and to help repair historical injustices and preserve cultural diversity. It's AI in service of equity and heritage.
Okay, proactive applications. What are some key examples? The report highlights access to justice. We know the justice gap is a huge global problem.
It's massive. Access to basic legal information and representation is recognized as a fundamental human right. But for billions of people around the world, it remains effectively out of reach. Legal systems are often too complex, too expensive, too slow, and this justice gap disproportionately impacts low-income communities, marginalized groups, women.
So how can AI help here, generatively?
Generative AI, specifically large language models, offers a potential generational opportunity to start dismantling some of these barriers. For the public, AI-powered chatbots can provide immediate, accessible, plain language information about basic legal rights and procedures. The report mentions examples like Legal Aid of North Carolina using a chatbot called LIA to help people navigate issues like domestic violence or disputes with landlords.
So democratizing basic info, what about for lawyers themselves, especially those working in legal aid or pro bono?
For those chronically under-resourced lawyers, AI tools can be a massive force multiplier. They can automate time-consuming tasks like reviewing large volumes of documents, conducting initial legal research, even drafting standard briefs or court forms.
Freeing up the humans.
Exactly. It frees up the human lawyers to focus on the high-value, uniquely human tasks, deeply advising clients, developing case strategy, negotiating complex settlements, appearing in court. This allows them to serve significantly more people effectively with the limited resources they have. AI could also power smarter referral systems, guiding people to the most appropriate legal service or support organization for their specific problem.
But obviously, using AI for legal advice carries risks. Accuracy, confidentiality,
Right.
ethical oversight must be paramount.
Absolutely non-negotiable. The report stresses the need for stringent oversight. Legal bodies like the American Bar Association are already developing guidelines to address key concerns, ensuring the accuracy and reliability of AI-generated legal information, protecting client confidentiality, preventing the unauthorized practice of law by AI, and making it crystal clear that human lawyers retain ultimate professional responsibility for the advice given. But when implemented responsibly with these safeguards, AI truly does have the potential to make a significant dent in the justice gap.
Okay, access to justice is one key area for generative justice. What's another? The report mentions cultural heritage preservation. How does AI help there, and how does it connect back to countering that ontological erasure we talked about?
This is a really crucial and, I think, hopeful application. It directly counters the epistemic harm and ontological erasure by providing revolutionary new ways to restore, understand, interact with, and share diverse cultural heritage, especially heritage that has been damaged, lost, or marginalized.
How specifically?
Well, generative AI models, trained on detailed scans, photographs, or historical documents, can be used to digitally restore damaged artifacts, like reconstructing missing parts of a sculpture or even virtually reconstruct entire historical sites that have been destroyed or degraded over time.
So people could experience them virtually.
Exactly. This allows for the creation of immersive virtual reality or augmented reality experiences, making heritage accessible to people globally, regardless of geographical barriers. Imagine being able to virtually walk through a highly accurate digital twin of, say, the ancient Library of Alexandria or a lost temple. It can also be used for monitoring deterioration in real sites.
That's amazing. What about unlocking lost knowledge?
A spectacular example is the Vesuvius Challenge. Researchers used higher resolution CT scans to look inside papyrus scrolls that were completely carbonized, essentially turned to charcoal by the eruption of Mount Vesuvius in 79 AD. These scrolls were completely unreadable for nearly 2 millennia.
And AI could read them?
AI algorithms were trained to detect the subtle differences in the scanned structure left by the ancient ink, allowing researchers to digitally unroll the scrolls and begin deciphering the texts within. They're starting to reveal lost philosophical works and other writings from the classical world. It's like unlocking hidden time capsules. And it goes beyond just recovery. AI can make history interactive. The report mentions a University of Miami course where they experimented with generative AI to create personalized historical narratives for students, and even a chatbot avatar of the medieval philosopher Maimonides, trained on his extensive writings, that students could converse with. AI transforms preservation from static archiving into a dynamic, ongoing dialogue with the past.
So AI as a tool for cultural memory and revival. Okay, we've covered the architectural shifts, the proactive applications. Now, how do we actually implement all this globally? The report proposes a blueprint, a coordinated, multi-layered approach. Can you walk us through those layers?
Yes, it argues that realizing the potential of AI for good while managing its shadows requires integrated action across 5 critical layers. It has to be systemic.
Okay, layer one.
The material layer. Internalizing environmental costs. This loops back to the energy and e-waste issues. The key recommendations here are, first, establishing that global carbon tax for computation we discussed. Ideally, a harmonized framework, maybe coordinated via the OECD or the UN, covering data center energy consumption. This internalizes the environmental cost, driving investment in efficiency and renewables. Revenue could potentially seed a global fund for green AI research.
And the e-waste part.
Second, mandatory global circular economy standards for AI hardware. Building on things like the EU's existing directives, this would mean international standards mandating things like modular design for easier repair, restrictions on hazardous materials, and crucially, extended producer responsibility (EPR) schemes.
Making the manufacturers responsible for the whole life cycle.
Exactly, making them responsible for collecting, refurbishing, or recycling the hardware at its end of life.
Okay, material layer, layer two.
The technical governance layer. Building verifiable and democratic systems. This is about operationalizing those trustworthy architectures. It means actively promoting and funding the development of those verifiable DAO models. Governments, foundations, international bodies should support open source toolkits and create supportive legal frameworks for these hybrid models that combine democratic oversight from stakeholders with the technical assurance of verifiable AI and attestable audits. The goal is to empower communities to actually govern the AI systems affecting them and mandate these secure, verifiable checks.
Got it. Layer three.
The cognitive ethical layer. fostering ontological fluency. This tackles the digital colonialism and erasure head-on. It requires, first, significant investment in creating those pluriversal knowledge graphs, PKGs. This can't be done by tech companies alone. It needs a global public-private consortium funding deep interdisciplinary collaboration involving linguists, anthropologists, historians, philosophers, and absolutely centrally, indigenous knowledge keepers and representatives from diverse cultural communities worldwide. The goal is a truly pluralistic knowledge architecture for AI.
And the interaction methods.
Second, funding and research needs to be directed towards developing and refining those decolonial AI methodologies, the advanced context engineering, the sophisticated prompt scaffolding techniques designed specifically to guide AI away from its default biased colonial patterns towards more nuanced, culturally sensitive, and ethically reflective reasoning.
Makes sense. Layer 4.
The human social layer, redefining skill and ensuring control. This connects back to the EPOCH skills and the recursive replacement loop. First, it calls for a global educational shift. National education policies, university curricula, workforce development programs, they need to reorient away from training task-specific skills vulnerable to automation and prioritize cultivating those EPH competencies. Critical thinking, ethical reasoning, cross-cultural understanding, systems thinking, purpose-driven direction.
And ensuring human control. That sounds critical.
Absolutely critical. The second point here is the urgent need for international dialogue, likely spearheaded by the UN, to establish clear red lines on the development and deployment of fully autonomous, recursively self-improving AI systems, especially any that could automate complex normative or ethical judgment. The report argues that the creation of systems that could potentially escape meaningful human oversight and control poses profound existential risks. The principle of meaningful human control over high-stakes AI systems must be a non-negotiable international norm.
That's a strong stance. Okay, the fifth and final layer.
The justice layer, funding, reparation, and equity. This is about operationalizing generative justice. It proposes allocating a portion of the revenue generated from that global computation tax from Layer 1 into a dedicated global fund for generative justice.
What would this fund do?
It would provide grants and resources specifically for projects using AI to achieve positive social outcomes. Initiatives aimed at closing the access to justice gap globally, projects focused on preserving endangered cultural heritage, especially for marginalized communities, and the development of AI applications explicitly designed to serve the needs of historically underserved populations.
And the epistemic reparations aspect.
Crucially, the report argues this fund should also be used to establish and sustain permanent, independent, well-resourced platforms dedicated to epistemic reparations. These platforms would empower communities harmed by historical injustices, colonialism, and ongoing digital age harms to record, preserve, archive, and share their own stories, histories, languages, and knowledge systems in their own ways, reclaiming their fundamental right to be known and ensuring their worlds are represented authentically in the digital age.
Wow. Okay. That is a comprehensive, ambitious blueprint across all those layers: material, technical, cognitive, human, and justice. So bring this all together. We've journeyed through the incredible promise of AI for social good, but also stared directly into the profound material and socio-ethical shadows it casts. We've explored the deep architectural shifts needed, technical, cognitive, human-centric, to build a more just and sustainable future with AI. It's crystal clear that AI is not some simple tool or inevitable force. It's complex, powerful, and demands incredibly intentional design, governance, and ongoing critical engagement from all of us.
Absolutely. I think the key takeaway from the report and our discussion is that architecting AI for genuine social good is not primarily a technical problem to be solved by engineers alone. It is, fundamentally, a continuous and deeply complex political, ethical, and cultural process. It demands that we move beyond naive techno-optimism or cynical techno-fatalism, for that matter, and instead confront head-on the profound material footprint and the deep-seated social and ethical shadows of our current trajectory. But the report also offers hope. By consciously building this new foundation, one based on material sustainability, verifiable and democratic governance, truly pluriversal cognitive architectures, and a renewed focus on those uniquely human EPO skills and the proactive goals of generative justice, we can begin to steer the awesome power of artificial intelligence away from a potential future of increased extraction, inequality, and control, and towards a future that is actually more just, more sustainable, and genuinely worthy of the incredible diversity of all humanity.
That's a powerful summary. It leaves us with a lot to think about. Here's a final thought, building on everything we've discussed. What if the true measure of an AI's intelligence isn't really how well it simulates human thought processes, or how efficiently it completes tasks? What if the real test is how effectively, how respectfully it helps us remember, understand, and perhaps even honor the rich diversity, the pluriverse of all the human worlds it inevitably interacts with? What stands out most to you as you reflect on this deep dive?